Good afternoon. So, thank you everybody to come to Apsara conference this year. I'm so honored to be here to present to you. Actually, I was in Paris during the Olympics. I felt so excited, and I feel so proud. And the video you just saw, the old video colorization, actually my team contributed to that effort. So I feel very proud about that effort. So today I will talk about, I think you hear so much about data and AI today. I think from Jason, from Feifei, from I think many times. Today I will talk about how us, so the big data and AI platform team contributed to the AI native revolution. So Alibaba Cloud provides the most, I would say, the most advanced full stack AI products and services. So as you know, the only 2 cloud providers in the world who has both the cloud infrastructure and build their own foundation models. So one is GCP, and the other is Alibaba Cloud. So Alibaba Cloud has a global infrastructure. I think Jason already mentioned that. It's a global region, 87 availability zones. And so the big data and the AI platform is built on top of that. We have both, I think, the data governance platform. We have the cloud native big data platform. We have the AI platform called Platform for AI Pi. Now we have open source big data platform, and we have AI search services as well. So on top of that, you can see the Tongyi. You probably heard about the Tongyi Queen models many times during the conference. So the model is built on top of our platform. And Alibaba Cloud provides various Tongyi models from smaller size to all the way to the biggest size with various capabilities. The cloud has evolved in 3 stages, from IaaS, infrastructure as a service, to platform as a service, and to model as a service. Model as a service was a term coined in the Apsara conference 2 years ago. Now everybody accepted this term. The application on top of these service, on these platforms, they also changed in 3 forms. Infrastructure as a service, most applications just use virtual machines, open source software to build applications. Platform service, I think cloud native serverless becomes the norm. And on model as a service, the large language model centric AI native applications are become popular today. So what are the key elements to build AI native applications? First and foremost, you need a very advanced AI models. So the capability of the AI model decides the ceiling of your application. The more powerful, I think your application becomes smarter and easier and better. Secondly, because AI model is so expensive to train and to inference, so we need a very high performance AI platforms to do that. And third, data is the core for AI models and for applications as well. So during the AI native application building, you need all those different data from structured to unstructured to semi-structured data, so that you would like to have a unified data platform. I will briefly talk about I would say the 6 pain points to build AI native applications from concept to reality. So first is how to process unstructured data. Unstructured data in the form like text, like image, like video, is gigantic. There's so much unstructured data, and we don't have a single easy way to manage or to process all this data. Secondly, large language model, they can hallucinate. they don't have the latest information. So data freshness is a very high requirement to build an AI native application. Third, because building an AI native application involves so many different components, we would like to have an integrated tool and a platform such that you can easily build the whole thing end to end. And the fourth, of course, the AI model capability needs to be enhanced, and it is being enhanced. I think every month, every week, the new models or new capabilities coming out. Now, of course, cost optimization for AI training and immersion, which is super important for everybody, every application to start using AI capabilities. It's could be very cost prohibitive. It was very expensive. I think during the past maybe half a year to 1 year, the inference cost has dropped remarkably. But again, now people start to use more tokens during inference. For example, chain of thoughts, OpenAI, O1 models, that they use significantly more computing power during inference time. So inference cost is still a problem. Now, last definitely not the least is about protection of data privacy and security. Large language model often you can view it as like a black box. You don't know what it's doing, and you don't want it to leak data, and you don't want it to generate harmful result. So first I will talk about unstructured data. So what do we do as a big data and AI platform? We traditionally have the data in data lakes. So data lake is built on top of OSS, the storage service provided by Jason's infrastructure team. On the data lake, you have a traditional data warehouse formats like Iceberg, Delta, and Apache Pymon. But in addition to that, for unstructured data, there's lots of files like image, like video, like text, like PDF files, all those unstructured data. Now, in addition to files, you also have a model, like various large language model in various stage, and you also have I think model data sets and model feature sets. So we have this metadata service called the data lake formation, which can manage and incorporate all this data into a single metadata service, such that you can manage the unstructured, structured, and semi-structured data in a single place. And of course, we need to provide an enterprise level for security, permission control, and I think the goal is that we can provide the data lake to all the processing engines such that a single copy of data can be used by different engines. It's truly one copy of data instead of have a silo of data. And to help, I think, manage the files easier. For example, what if you have billions of files in the data lake? Today, you have to write scripts to process them very, I would say, inefficiently, right? So we introduced the object table into max compute such that you can view the billions of files as a table, as a single table in a max compute, such that you can use your traditional big data processing capabilities to manage all these files. You can run SQL query, you can write Python processing to easily process this data. For example, you can do count, you can do filter, you can do sort, and you can do processing as well. And in addition to that, we also provide performance acceleration, so we can cache all the metadata, we cache all the content of the data smartly for you. And of course, query optimization is a key capability of a big data system. So if we run a query against the billions of files, we can finish in seconds, instead of if you do using a traditional script, it can run hours or days. And another way to process unstructured data is to use embedding, to vectorize all these unstructured data. So, no matter it is an image, it's video, it's strings, or it's text, we can all vectorize it such that it can be used in a uniform way. So we are happy to announce that we released a new vector engine on Alibaba Cloud called Milvus. Milvus itself is an open source vector engine, and it's probably the most popular vector engine in the world. It has 29.5K stars on GitHub, and it has capabilities, very high performance. For example, search trainers vectors within milliseconds, and can do sparse and dense vector, multi-dimensional vector search, and it's highly elastic, can be scale up, scale down in seconds. So let's talk about the data freshness for AI native application and how we can help. Traditionally, big data processing in terms of freshness can be divided into 3 different approaches. One is streaming processing, one is incremental computing, the other is batch computing. Each one has a different freshness and each one has a different cost structure. So the better things in the traditional way, each of them use different systems. You have to write a different code for each of these processing methods. And what we are doing today is we are adding unified we are adding unified capabilities to handle all these different data freshness needs to our query engines. First, I'm talking about the Flink. Flink is a real-time computing engine. It's like de facto standard for real-time computing. And we added called a Flink Uniflow, which is a real-time data lakehouse. And as you can see from the example here, so you have data from the source, you ingest it with the Flink CDC into the data lake. Then if you want to do like streaming processing or incremental processing, or you want to do a batch processing, you just need to use this new concept called Flink materialize table. So you create a materialize table, and you specify freshness requirements. I want it to be 1 minute, 5 seconds, 1 hour, whatever. Then you specify how you want to generate this data, right? So now we will pick the right execution mode automatically and intelligent for you. So we will decide whether it's incremental processing, it's streaming processing, or it's batch processing. And we manage the whole thing for you so that you don't need to worry. You don't need to learn how to do these things differently. So through this, we actually expand Flink into a full, I would say, batch and streaming, unified batch streaming processing capabilities instead of just the streaming or real-time computing. Not just to Flink, we also added this capability to Holograph. Holograph is our, I would say, fastest real-time OLAP engine. And we added a concept called a dynamic table into Holograph. So as you can see, it has similar capabilities. You can declaratively define what you want to do with the dynamic table definition, and you specify refresh mode, and you specify refresh interval, and you can change it easily from streaming to incremental to full, such that you get all the different capabilities very easily. I think it's doing streaming processing and batch processing in a unified way has never been easier. Of course, we also upgraded, or we also accelerated the data processing performance with various engines. So as you can, I gave you an example. I think for Spark, we we built a native execution engine called Fusion, and which is 3 to 5 times faster than the open source version, which has vectorized execution and SIMD instructions to speed up the execution. Similarly, for Flink, we created this Flash native execution engine, which is 5 to 10 times faster than the open source counterpart. And it's actually not easy to do it because Flink is a real-time computing with the states, and you need to manage both the execution, parallel execution, but also the memory access. So let's talk about the tools and the platform. So DataWorks, I think many people actually are familiar with the DataWorks, which is a very unique product from Alibaba Cloud. I think it's actually hard to find a counterpart in the Western world. So it's very capable, very powerful. Many people love it. So DataWorks is a intelligent big data AI platform for data lakehouse. So what it does is it manages data warehouse and a data lakehouse for you, and on top of that, it can do data integration, data development. It provides an IDE or notebook for you to develop your big data tasks, and it also does the task scheduling and monitoring. Of course, it also manages the data quality and the data governance, and it handles, you can use it to analyze the data as well. So we also added DataWorks Copilot such that it can do SQL generation and Python code generation for you. This is an example. So essentially, I want to show here is how in DataWorks, in one notebook, you actually can manage data and from data development to AI development in a single place. So here's the example. These are the data sets from, it's like a Chinese medical data set. And first, you can just do some casual analysis. In real time, you can see what's the data distribution for this data set. And after that, you want to do some data filtering. Say, I don't want data to be too long or too short, right? I can just do submit a task to pre-process data to filter data. After that, you can submit the filtered data into a Pi platform for AI to do a model tuning or a model training or model fine tuning. And once the model is generated, the model is being registered into an AI catalog so that you can use it, you can share and use it. And after that, you can then call the model inference service, and you can verify its effect in the notebook right away. What I try to say here is all this from data pre-processing, from training, from inferencing, from for verification, everything is done in a single notebook. And you don't have to switch back and forth. And so you can, this significantly simplify the development work for the AI developers. So with all that, so today, we are introducing the brand new OpenLake solution from Alibaba Cloud. So putting everything together, we have essentially we have a data lake, we have our data lake formation metadata service. Now we have all these computing engine on top of the data. And here, all the data is stored in a single place. It's shared across all these different engines, and you can use every engine to process the data. And then from development, you can use DataWorks to coordinate all these data and the different engines in a single place. This is why we call it OpenLake, such that the data is no longer siloed, and data does not belong to a single engine. Data is shared, and I think we'll have a video, but I will skip the video. So in addition to all those data processing, AI search is also part of OpenLake. So AI search is very popular today. So we have all these different capabilities, the building blocks for AI search, such that you can choose and pick and choose and to build your application. And I think the effect for your AI search application, I mean, can vary, depends on what you choose. And AI search actually is built on top of different search engines like Elasticsearch, our own Haven't Ask, and the Milvus vector search capabilities. I want to call the one thing is Elasticsearch. So we build a strategic relationship with the Elastic company. So today, actually they are here. Today, we upgrade our version of Elastic offering from Platinum Edition to the latest and greatest Enterprise Edition, and for free. So everybody gets it for free. So these are all the, I think, common application scenarios based on OpenLake. I will skip this one quickly, and let's talk about the AI capabilities. So Pi, which is a platform for AI, so our high-performance AI platform has been evolving rapidly, continuously. So this year in particular, we added, in addition to dense transformers, we added MOE and diffusion transformers into our foundation model capabilities, and we added reinforced learning, and of course, we integrate data processing, and we can evaluate your model. The model evaluation is also integrated, such that you can do model development end-to-end in one place. And this is an example how we do data processing for large language models and how we do it easily. You can see the templates, which actually can help you to process Wikipedia data, archive data, or maybe I think GitHub data as well, such that you can just plug in these templates right away. And we also added like image processing, video processing, keyframe extraction, all these capabilities into the platform, such that you can do multi-model data cleansing and processing. And we can visualize the whole thing for you and manage the data dependency and the life cycle for you. So you don't have to track all this by hand. So I think everybody cares about capacity and cost, right? So in the past year, from September last year to today, we actually increased our effective computing power by, I think, by more than 10x. So this includes both building physical clusters, AI clusters. During the past year, we built, I think, many of them. But also, from software point of view, we increased our cluster utilization rate to 90%. This also adds to this improvement as well. And from performance point of view, this is a Pi ES, which is our inference engine. And with our own Blade LLM optimization engine, we actually reduced the latency, time to first token and time per output token significantly, and also improved the throughput token per second by more than 80%. We also do the global scheduling as well, such that we can schedule your task closer to the user, but also try to balance the cluster utilization across the globe, such that whenever there's a capacity, we can schedule your job over there. And training and both training and inference become popular today. So we have to have a unified training and inference schedule today, such that the cluster can be used for both tasks. We added significantly more capabilities to support multi-tenancy and to support dynamic workload. If you have fragmented resources in your cluster, we actually can put that into use. That's how we improved the cluster utilization to more than 90%. You can see this is the actual heat map from our cluster utilization. Now. And from training side, we upgraded our Pi DLC, which is our training service. So here, one thing I want to call it is we make all this into a serverless AI platform such that you don't need to worry about many of the dirty details. For example, node failure, GPU failure, and we handle it automatically for you. And yeah, let's talk about last data privacy and security. So we build both, I think, pausing data cleansing and also we added confidential computing containers. This is a very, I think, a brand new technology to have a trustworthy computing. And then we, for your prompt and result, we also have filters built in for you to filter out harmful result.